A join is a relational mechanism for combining two tables into a single result set. Now, on a good day, we combine the correlated data from two tables into a single result set. For example, I've got an invoice header in one table and multiple invoice details in another. So when I join those two tables together, I am going to hopefully put corresponding headers with corresponding detail rows. In order to do that, we describe a join condition. That join condition describes how the tables are joined. However, if we do not do that, we'll get a very large result set called the Cartesian product, wherein every row in the first table is joined to every row in the second table or succeeding tables. By the way, if anybody ever tells you that they've got a box which is so powerful that even you cannot push it to its knees, write a Cartesian product against several large tables, and I assure you that person will apologize to you for lack of confidence. Joins along with the where and the having clauses do limit the size and the result sets for particular queries. So let's start digging into this. In order for the optimizer to evaluate how to resolve the join, and let's just take another half step back and say that SQL Server has a cost-based optimizer. Cost-based optimizer means that we identify what the possible approaches are to resolving the query, and we identify how much we think it's going to cost to perform that particular plan. Once we've got that particular plan, we use it. It needs a lot of information in order to make intelligent decisions along those lines. Specifically, it needs to be able to analyze the possible join orders. Are we joining from table A to table B, or are we joining from table B to table A? Now, you can take a look at the plans and identify the join order that it does select, but bear in mind that the costs of the join are very significant in opposite directions, and we will quantify that in a few minutes. Next, at join order optimization time, we need to know whether there is a matching index for the join. One of the more common situations I've seen in poor join performance is a situation along the following lines. You're joining from table A to table B, but table A to table B is a many-to-many relationship. So in between, we have table AB. So we join from table A to table AB to table B. That is a very common thing to do, but what happens frequently is that when you're joining that way, you have an index on that AB table on A comma B. When you do that, that means that going from A to AB is relatively easy because you're indexed to go in that direction. However, joining from table B to table AB can often be non-trivial, particularly if you only have an index on AB and not an index on BA. What that means is that you sometimes get very interesting index selections out of your joins, and this may not be the index that you're expecting because of the join order that the server is being forced to take. I had a performance gig, and by the way, I do between 20 and 40 performance gigs a year, almost always at different client sites. I have a lot of clients that bring me back on a regular basis, but I also get a lot of new ones depending on the year. And this particular one was an insurance company up in the Northeast. I will not tell you where because you'll know which insurance company it was. But this was exactly the problem they had. They had rolled their application into production, and in test, their response time was in the under 2-second range, which they deemed acceptable, but when they went into production, their response time was in the 20-minute range, which obviously was considered unacceptable for an online app. When they brought me in, this was the situation identified. They were joining from table A to table B through that junction table AB, and we only had an index on AB. Adding the index on BA allowed it to join in that order, and all of a sudden the response time was 2 milliseconds instead of 20 minutes. There are situations where you do add indexes in production, and that was one of them, and that was one where they got calls asking, hey, did you change something, because all of a sudden it's fixed. When evaluating the join order, the server already knows the best index for each search argument, any OR clauses, and join clauses. What does that mean? The server, when it goes through optimization, goes through a number of steps. One of those steps is identifying what the valid search arguments are. And again, for those of you who were able to attend the previous webinar, that's something that we talked about. The best search are the best index for any of the OR clauses and the best index for the join clauses. And at that point, we start evaluating the join orders. Now, keep in mind that in the olden days, olden days being, SQL 2000 and earlier, the official party line, even though it wasn't true, is that the server evaluated all possible join orders. That wasn't true then if you were over 4 tables in the number of joins, but today that's even less true because it's got a variety of algorithms that it goes through to identify what join orders might make sense. And as a result, it tends to find optimal join orders more quickly based on how much information it's going after. So where it says the server evaluates all table sequences and join indexes, that's only mostly true. It does estimate the cost, and it does choose the fastest query plan. Note this is another change of behavior from the older SQL Server behavior, which was the cost that brought back the least I/O. Today, in the parallel world, it is the fastest query plan that it looks at.